starting point of any PC build is the goal of the machine. What will the PC primarily be used for? For gaming, video editing, 3D modeling, AI? This project features a set of components that have two primary goals in mind. Roughly 70% of the time it will be used for video editing and Photoshop, and the other 30% roughly for gaming. So the components I chose target those two specific scenarios. Before we go through each component and why it makes sense for this build, I just want to quickly mention that I'll be installing a special version of Windows on this PC that many of you in my regular audience probably have never heard of, and that's Windows LTSC, which is an enterprise version of Windows that comes out of the box de-bloated, with no Cortana, no Copilot, no spying on you, no Microsoft account nonsense, and with extended support. You can't get this version of Windows through Microsoft though. You have to use a service like today's sponsor URcDkeys, who are now selling official OEM Windows 10 and 11 LTSC keys for a ridiculously low price. When time comes to install Windows, I'll go through how to get access to this version of Windows that we all wanted but that Microsoft refused to give us. Starting with what is probably the most divisive component, the CPU. Like I said earlier, the goal of this machine dictated the choice of an Intel CPU instead of an AMD one. In the build I did a few months ago, I went all AMD and featured flagship class components, including an AMD CPU, because that's what made the most sense for that specific use case. The goal of that machine was audio production, and this PC will be used for mostly video editing and related tasks, with gaming as the secondary focus. If this was a gaming focused build, then something like the 9800X3D or 9950X3D from AMD could be better choices. But instead I'm going with the 285K, Intel's current consumer grade flagship, which was kindly provided by Intel for this project. While the GPU will be doing most of the work in DaVinci Resolve, personally I found Intel CPUs to offer better stability and better timeline performance compared with AMD CPUs. Also, the I/O on Intel platforms also seems to be more stable, and I use a bunch of external drives and whatnot for moving footage around, so having a rock-solid system where I can saturate the I/O without things dropping off is crucial. But what about gaming? Won't the 285K limit gaming performance compared to the AMD flagships? Well, not when gaming will be done almost exclusively at 4K, where the GPU is the bottleneck. And that brings us to the GPU choice. The graphics card I chose is the RTX 5090, Nvidia's flagship at the time of making this video. Unfortunately, despite me nagging every AIB out there, no one had a 5090 they could contribute to this project, so I had no choice but to shell out over $2,000 on a component that puts pixels on screen. Was it worth it? Yes and no. I'll discuss in a moment my thoughts on the 5090, but seeing as this was meant to be an epic build for the channel, there was no other GPU that made sense but the monstrous 5090. My good friends at BeQuiet once again sent over a bunch of epic components for this project, and while in the build I did a few months ago I used the colossal Lightbase 900, this time BeQuiet sent its little brother, the Lightbase 600, which retains most of the features of the larger case but comes in a more manageable size. It's absolutely stunning, and like the 900, the 600 also allows for vertical, reversed or horizontal configurations. It's a joy to work in these dual chamber spacious cases, that's for sure. BeQuiet, being the German engineering experts that they are, offer a series of cooling components that have excellent cooling performance along with quiet operation. Their products are extremely well built and feel very premium. So to keep the 285K nice and cool, BeQuiet provided their latest 360 rad, the Silent Loop 3, which has this really awesome looking pump block. They also provided matching RGB fans to go with it and a bunch more Lightwing LX 120mm fans to populate the whole case. These performance fans are really even in color and are dead quiet. My good friends at GSkill provided a baller kit of RAM for this project. Actually, I should apologize to GSkill because it took me several months to put this build together, and although at the time this was GSkill's flagship kit of CUDIMM memory, in the months since they sent this over, they've released released even faster kits for Intel 200S platforms. This particular kit features 2 sticks of 24 gigs for a total of 48 gigs of system RAM, which will be plenty for the type of video projects that I work on for the channel. It's an 8200 CL40 kit, so the latency is up there, but I'll go over the BIOS tuning later, which will improve latency considerably. For the motherboard, I chose the Tomahawk Z890 from MSI, as it's currently the best Z890 motherboard under €300. In fact, this board is so good it makes high-end motherboards mostly irrelevant. It can go up to 192 gigs of RAM in dual channel, and it has one PCIe 5 X16 slot and another 2 PCIe 4 slots. It has 4 M.2 slots, one is Gen 5 at the full 128 gigabit per second, and the other 3 are Gen 4. So even with the top PCI slot packing an RTX 5090, you don't get gimped on drive performance, as the top M.2 slot will still run at full speed, something that wasn't possible on Z790, which came out less than a year ago. And then there's Thunderbolt 4 ports via USB-C, supporting real 40 gigabit per second speeds, 8K displays, daisy chaining, and USB 4 compatibility. And for networking, there's a killer 5G LAN NIC and Intel Wi-Fi 7, and there are multiple USB-C 20 gigabit ports, multiple USB 10 gigabit and 5 gigabit ports for fast data transfer. There's HDMI 2.0 video output supporting up to 8K 60Hz through the iGPU if needed. I mean, these are all high-end specs in a board that costs less than €300, so it's hard to justify anything else. I do wish the I/O on the back had legacy USB 2 ports, but it's not a deal breaker. Now, you can't power an overclocked 285K in an RTX 5090 with just any PSU, and guess who sent over an absolute unit of a power supply? BeQuiet did. That's right, there are expert PSU makers also. This is the Dark Power Pro 13, which can provide 1600 watts of power at 80 plus titanium efficiency, with quiet operation of course, and it has a really interesting overclocking feature that lets you separate the 12-volt rails, and it features 2 of the infamous 12V2x6 16-pin connectors, so you could power 2 5090s with this monster of a PSU. All of the cables are braided with really high quality material, and they include what I would call an excessive amount of Velcro straps for tidying up your system, or if you are a crazy person, to use as an extremely stylish armband. This PSU feels premium through and through. BeQuiet really did an amazing job here. Now, I did have another partner lined up for storage, but unfortunately their drives didn't make it in time for the build, so I'll be using a Samsung 990 EVO for the OS drive. This isn't PCIe 5 fully, it's a hybrid drive with 2 PCIe 5 lanes and 4 PCIe 4 lanes. The idea being that this can be a great OS drive for short bursts via the PCIe 5 interface, while still being a good low power drive for sustained transfers. In practice, I haven't really noticed much of a difference between PCIe 5 and PCIe 4 drives, to be honest. Not enough to justify the price difference, that's for sure. And I'll be populating every drive slot on the motherboard with drives from my previous video editing rig. These in the footage are just for demonstration purposes. Building in the light base 600Ks was a joy. I'm at that age where I just don't have the patience anymore to be doing SFX builds, as sweet as they end up looking, and this spacious case offers everything I look for in a chassis. I set up the fans with positive pressure, pushing as much air out as possible, pulling in air from one direction and having every other pushing air out. I find that this configuration works really well when you have these many high quality fans. In a smaller case, I would probably set things up a bit differently, and the end result is truly epic. This build looks incredible. The RGB lights on the fans, pump and ram look awesome and consistent. I ended up choosing this bluish white theme as it looks great through the tinted glass panels, and I prefer a slightly more subdued look versus the whole rainbow RGB fest that some people prefer. Now, before we move on to performance and test out a few games, and before I give you my final thoughts on the build and in particular of the RTX 5090, like I said earlier, I'll be installing a special version of Windows Windows here. If you don't know what LTSC is, it's an enterprise-grade version of Windows without any of the bloat that comes with stock Windows 10 and Windows 11. There's no spying from Microsoft, no Copilot, no nonsense. And even though Microsoft is ending support for Windows 10 soon, the LTSC version will continue to get security updates all the way up to 2032. That's right, you can keep Windows 10 fully supported with this version for many years to come. And the best part is that our longtime sponsor URCDkeys.com offers official OEM's Windows 10 and 11 LTSC keys for a ridiculously low price, with Windows 10 LTSC costing just over $10 when you use my coupon code C25. And I chose Windows 10 instead of Windows 11 because I found that it offers better gaming performance and I prefer the UI on Windows 10. Now, since Microsoft doesn't allow consumers to buy LTSC directly from them, you need to download an ISO image of the OS from another source. I'll put a link in the video description to archive.org where you can find the clean LTSC ISO that I used. You'll then need to use the Rufus app to create a bootable USB drive. Follow the link in the description to the Rufus page and download Rufus. Run Rufus and select the Windows 10 LTSC ISO you downloaded from the link in the description, or the Windows 11 LTSC one if you prefer that. Then choose Standard Windows Installation, GPT Partition Scheme and UEFI non-CSM. Keep the USB stick formatting to FAT32. Now hit start and you'll be given a few options. You can create a local account. I chose Cortex in this example, so that will skip the whole create an offline and online account shenanigans during Windows install. You can also disable data collection, so it will skip the annoying privacy questions during Windows install. Now there's an option to disable BitLocker, and for Windows 11 there will be an option to disable Secure Boot. Leave these unchecked or you'll run into trouble with anything that requires Secure Boot. For instance, Battlefield 6 uses kernel level anti-cheat, which requires Secure Boot, so if you disable it you won't be able to play the game. Rufus will create the bootable USB for you, and while you wait you can head over to urcdkeys.com to buy your LTSC key. There will be links in the description to get to this page directly, or you can go to urcdkeys.com and search for LTSC. The price is set at just under $15, but if you use my coupon code C25 you'll get an additional discount, bringing the price down to roughly $11 at the time of making this video. Submit your order and pay with credit card or PayPal. I chose to pay with my credit card. And that's it. Now just head over to the purchased orders page and click View Keys and then click Get Key. Take note of the keys so that you can activate Windows. It will also be sent to your email address. Plug in your USB stick with the Windows LTSC install that you created with Rufus into your machine and boot from the USB drive. Then just run the Windows installation as normal and choose Windows 10 IoT Enterprise LTSC or Windows 11 if you're going with that. You'll notice straight away how much faster the install process is. After you've installed Windows, you'll have to install all of your system drivers, and that includes your motherboard, chipset drivers, GPU drivers, etc., and also install all the Windows updates. Like I said earlier, this version of Windows will continue to be supported until 2032, and it only gets security updates, no annoying feature updates that mess up the way you have everything set up. Once that's done, just type in activation in the Windows search bar and enter the key that you got from urcdkeys.com in the appropriate field. That's it, easy peasy. And man, let me tell you, LTSC is the version of Windows to get. It's crazy how snappy it feels with no interruptions, no nonsense from Microsoft, just a bare bones OS that gets out of your way, completely de-bloated with no random games and other crap installed by default. It's the Windows that we should have gotten from the start, and it's cheap. Go get it, I highly recommend it. It used to be the case that you had to fiddle about in the BIOS for an eternity to tune the memory and the CPU for optimal performance. But recently, Intel introduced the 200S Boost feature, which is basically a full-on overclocking profile that doesn't void your warranty. Just enable it in the BIOS. It should be clearly marked once you've updated your motherboard BIOS to the latest version. You can see how the memory in its stock configuration, without any profile enabled, had a ridiculous ridiculously high latency of 99.5 nanoseconds, but after enabling 200S boost, the latency dropped to 84 nanoseconds, which is still pretty high, but you have to keep in mind that this is a CL40 kit. With manual tuning you could probably get this down even further, so if you have a few days to waste on that, then by all means knock yourself out. Running Cyberpunk 2077 in a CPU bottleneck scenario, so at 1080p max with no RT and no path tracing, after the 200S boost was applied, I saw an average FPS of 219. I found some testing done by Kit Guru with the same exact settings, but using an AMD 9800 X3D instead of the 285K I'm using here, and they got an average of 237 FPS and 145 1% lows. So even with the 200S boost enabled on the 285K, the 9800 X3D is still 8% faster. But remember, that's at 1080p. No one is building a system with a 285K or a 9800 X3D with an RTX 5090 to then play games like Cyberpunk at 1080p. So at 4K, which is the resolution I'll be playing games at, Kit Guru got 79 1% lows and 101 FPS average, while my system with the exact same settings got 109 FPS average and 86 lows. So the 285K in my specific configuration is actually 8% faster at 4K in Cyberpunk 2077 than the one that Kit Guru used. Bear in mind that the Mary kit is not the same, and I'm using Windows 10 LTSC, whereas Kit Guru used Windows 11. It's not apples to apples, but the point I'm trying to make is that at 4K, the bottleneck is generally going to be the GPU. So if you are building a rig with the same goals as this one, where you'll be spending roughly 70% of the time doing video work and only 30% of the time playing games, I would argue that the 285K is a better option than the AMD equivalent, as at 4K there will be virtually no difference between CPUs in gaming, but the 285K offers several benefits in video editing and related workloads. This is why you should always keep the goal of the build in mind when building a PC. I'm not saying that there aren't any scenarios where an AMD CPU won't be a better choice. I'm saying that it all depends on what your goal is. We're spoiled for choice these days, so you might as well min-max your build to better suit your needs. For the rest of the games, I'll put the average FPS numbers on screen as I give you my overall impressions of the component selection for this project. Regarding the RTX 5090 specifically, I can tell you straight up, I haven't changed my opinion since I made a video when it was launched calling it a scam. I still think it's a scam and absolutely not worth paying over $2,000 for it. But for my specific needs, the 5090 is actually an absolute bargain. How can it be both a scam and a bargain? Let me explain. So one of the key selling points of the 5090 and the 5000 series in general is the improved ray tracing performance, as well as the latest version of DLSS and DLAA. Ray tracing looks fine, but it's not transformative compared to traditional techniques used for lighting. If game devs actually put in the effort when using traditional lighting techniques, they can achieve very similar results to real-time ray tracing, but with much better performance obviously. As for path tracing, it's simply not achievable with the 5090, we're not quite there yet. The path tracing mode in Cyberpunk runs at around 30 FPS at native 4K, which is just not an enjoyable experience. You can run it at over 60 if you turn on DLSS of course, but I can absolutely tell the difference between DLSS on and off compared to native 4K. I don't know what's wrong with most reviewers out there claiming that DLSS in quality mode offers similar image quality to 4K native. It absolutely does not. I guess it might have something to do with the size of the monitors they are using to test it. I play games on a 55-inch OLED TV from LG at 120Hz, and even though I'm not super close to the screen or anything, I can definitely tell the difference between DLSS on and off, and the quality reduction is evident. DLSS looks blurry in comparison to native 4K, even with the transformer model and in quality mode. It's nowhere near as bad as the first iterations of DLSS and FSR, but there still is a difference between the native 4K picture and DLSS. I'm not hating on DLSS or FSR or XeSS, mind you. I think these upscaling technologies are awesome in the right environment. For instance, when gaming with APUs, particularly in handhelds where the screen is so small that you won't notice much of a difference between native and upscaled. So anyway, real-time ray tracing is not transformative enough, and real-time path tracing requires DLSS for decent frame rates, making the two unique selling points of the 5090 not that enticing in my opinion. That leaves native rendering performance as the key factor for choosing the 5090 over a much more affordable GPU. Is the 5090 that good at native rendering? It definitely is, but at the end of the day it's just pixels on a screen. As I've said many times, I think you should first invest in an OLED and set up your system in such a way that you can connect your PC to a large OLED display and take advantage of HDR when it's well implemented. And only after that should you be thinking of investing in a high-end GPU. Recent rumors point to a 5000 series Super refresh, and if Nvidia launches the 5080 Super at around $1,500, then I think that would be the way to go if you want a flagship experience, as I expect it should be probably on the level of a 4090. The 5090 is not faster enough than a GPU in the $1,000 to $1,500 range to justify the $2,000 to $3,000 price tag depending on the model. Now, having said all that about the 5090, things dramatically change when you look beyond gaming. Remember that the goal of this machine was video editing, and man, this build is absolutely incredible in DaVinci Resolve. I can just throw raw 4K footage into the timeline without proxies and scrub through it like a hot knife through butter, even with a bunch of heavy effects applied to the clips. Stabilizing footage even with max smoothness is almost instantaneous. It's just incredible. Rendering is really fast also, but to me the scrubbing and overall timeline performance makes this build absolutely worth the investment, particularly the 5090. While the 5090 might not be transformative in gaming, it's actually kind of a bargain in a prosumer use case like this. Yes, the 5090 is a bargain if you are using it for anything other than gaming. Professional grade GPUs cost 3 times as much, mind you, and the 5090 feels to me like a professional grade card disguised as a gaming card. So for just over $2,000 for professional workloads, the 5090 is a no-brainer, and also give the 285K a second look. While it's nowhere near as efficient as AMD's equivalents, I think it offers a lot for the money, and for creative workloads especially, it's a fantastic CPU in my opinion. Very underrated. Check out Urcdkeys for your Windows 10 and 11 keys, as well as Office 2021 Professional, and again I highly recommend the LTSC version of Windows. Check the links in the description for your cheap official OEM keys, and use my coupon code C25 for an additional 25% off. Big thank you to Intel, to BeQuiet, and to GSkill for generously participating in this project. If you like this video, then give it a like. If you disliked it, give it a dislike. If you are new here, then subscribe, and consider joining my Patreon for exclusive access to the Cortex Discord server. Thanks for watching, and until the next one.